In this lesson, we're going to talk about compound probability. Probability is something you could go into for probably an entire year just studying probability and barely scratch the surface, but you're going to get a quick crash course here today with compound probability, specifically dealing with events, dealing with and or. There's going to be a lot of things I'll kind of go over quickly. I also won't focus too much on the difference between probability, chances, odds, all that stuff. So just bear with me. I know that I might use a decimal or a percent when that's technically one of those is probability and one of them isn't, but this is not the purpose. The purpose is more based on how do you set up a compound probability problem. All right, so let's start things off here. This is more notation that a textbook will use, but I'll be honest, I really don't use this notation too much. So the official definition for finding the probability between the union of two events, basically what I like to call an OR problem, is you take the probability that the one thing happens plus the probability that the other thing happens minus what I like to call the overlap. So the way that I sort of refer to this is that the probability of one thing or another thing happening is the probability of the first thing happens plus the probability of the second thing happens minus the overlap. So for example, if I wanted to find the probability that it rains, let's say Wednesday. Sorry, this pen's not working too nice here. Or Thursday. To find that, I would find the probability it rains Wednesday, which maybe I could find in my weather app, plus the probability it rains Thursday, minus the overlap. And in this case, we'll talk about how to find this later. The overlap would be what's the probability it rains on both Wednesday and Thursday. And that's something we could calculate with something I'll show you in the second half of the lesson. So anyway, let's try out a few examples here and it'll start to make more sense. Okay, and if you don't have a picture of a deck of cards or you're not great with a deck of cards, if you do a quick Google search, you could find a picture of just all the 52 cards in a deck of cards, and this will make this a little bit easier if you're not too familiar. But if you are familiar with cards, this will be kind of helpful. So the first question says, one card is drawn from the top of a 52 card deck. Find the probability of drawing a heart or a face card. So the way I'm going to set this up is just like we did before. We're going to say, and this is sort of the formula that we're looking at here, this probability of one thing or another thing happening. So we're going to say the probability of a heart or a face card, those are just all the cards that have a face on it, is equal to the probability that we draw a heart plus the probability we draw a face card minus the overlap. Okay, so now we just have to think through a deck of cards. So in a deck of cards, there's 52 cards and there's 4 suits. So if we take 52 divided by 4, there's 13 cards in each suit. So that means there's 13 cards in the deck that are hearts. And if you're looking at the picture of all the cards, you could just count up all the hearts and there's 13 of them. Face cards. So if you count out all those face cards there, the cards that have faces on it, there's kings, queens, and jacks, and there's 4 different suits for each of those. So there's 12 of those out of the total of 52 cards. Now, this is a limited way of looking at this, though, because if we take the 13 cards that are hearts and the 12 cards that are face cards, we've actually double counted some things. We've counted some cards here and here that we don't want to count twice. So think about this for a second, and if you have that picture, it's very helpful. What would be the overlapping cards in this case? And in this case, the overlapping cards are going to be the cards that are both hearts and face cards. So basically they're falling into both of these categories, hearts and face cards. So now if we think about that, there are 3 cards, there's the King of Hearts, the Queen of Hearts, and the Jack of Hearts, that are hearts and face cards. And we counted them once in the face cards and once in the hearts. So if we subtract these, that'll kind of get rid of the fact that we counted them in both the hearts and the face cards. So now what we'll do from here is we're going to simplify this. We're just going to add this up. We'll get 25 over 52 minus 3, so that's going to be 22 over 52. And then if we reduce that fraction, I'll leave this one as a fraction again. I'm not going to get too much into the differences between probability, odds, all that stuff here today. So we'll leave it as a fraction as just 11 over 26. You could turn it to a decimal. You could write it as a percent. There's a whole bunch of different ways you can represent these chances, probabilities, odds. Okay, you're free to pause the video, try the next one on your own, but I'm going to start this one here now. So if we want the probability of drawing a spade or a queen, and I will do my best to draw a spade here. They are not my strong suit here. So we got the probability of a spade or a queen is equal to the probability we draw a spade plus the individual probability that we draw a queen minus the overlap. So if we think about it, spades and hearts, actually, there should be the same amount of them. That's just a suit. So that's also 13 out of 52. If you count them up, there's 13 spades in the deck out of 52 cards, plus there are 4 queens in the deck out of 52 cards. Now, we've got spades and queens, but there's some cards or card that we counted twice. Again, take a second, see if you can figure out what that overlapping card is. And in this case, there's only one. It should be the queen of spades. It falls into both of those categories. So there's one card out of the 52 cards that we counted twice, and we only want to count it once. So if we subtract this here, we're going to get 16 out of 52. And I'll leave it to you guys to reduce that fraction. Again, I'm not super concerned with that right now. You could write this a whole bunch of different ways, but obviously that fraction could be reduced. Now, with our last example here, we'll do the probability of a jack or a king. So we'll have the probability we get a jack plus the probability we get a king minus any overlap here. And to figure this one out, we'll first start with the probability of a jack. So there's 4 cards out of 52 that are jacks plus 4 cards out of 52 that are kings. And now if we think here for a second for the overlap, it is possible there isn't any. So there's no card that's both a jack and a king. There's no secret, face card that's a jack and a king at the same time. So since that happens, there really isn't any overlap here to subtract. So this would just be 8 over 52. And again, if you'd like to reduce that, you can, but for now, not too concerned about that. And this can also be incorporated as well with statistics. So if we look at something like a survey dealing with maybe drug and alcohol use that you sometimes see posters of around your school, this one says, a survey was conducted on Hershey High School student drug and alcohol use. 20% of students admitted to taking recreational drugs, and 30% admitted to drinking alcohol. 15% admitted to taking both drugs and alcohol. What percent of students took drugs or alcohol? So again, we're kind of looking for that or problem here. What percent took drugs or alcohol? And since we're looking for this sort of or lineup, we're going to have to do this similar setup. So we're going to take the probability or the percentage of people that do drugs or alcohol should equal, and I'm just going to abbreviate here, the probability of drugs plus the probability of alcohol minus, again, what we'll call the overlap here. Now, so we'll start off with the probability of drugs. So 20% of students admitted to taking recreational drugs, so I'll just put a little 20% in here. You could write it also as a 0.20 if you wanted to use decimals, that's okay too. Plus 30% admitted to doing alcohol, so we'll put that here. And now where a lot of people goof up with statistics like this, they'll look at these numbers and they'll say, oh my gosh, 50% of people are doing drugs and alcohol. That's insane. But this isn't really an accurate portrayal because in this 20%, some people might be doing drugs and alcohol. And that's what we need to subtract here. So this extra 15% at the end is going to be our overlap. It says these people took drugs and did alcohol. So we'll have to subtract 15%. And if we subtract this 15%, we should end up with a final answer here of 35% of people using drugs or alcohol. So that's an introduction to OR problems with probability. I'm going to talk more in a little bit about AND problems and maybe some dice probabilities here too. So stay tuned if you want to follow along with those videos as well. We'll get a little bit more into probability.